So this is section 11.4. We're going to continue working with conic sections. We talked a little bit before this video started about some of the applications of the conic sections. But what I want to move to next is being able to identify the conic sections. And so that's going to be looking at equations like this and saying, oh, I've got a circle, or I've got an ellipse, or hyperbola, or a parabola. Now, there actually is one other term that I could have put here. It's kind of an XY term, but we're not going to deal with that. That's going to be a rotated conic. Instead, let's focus on this. And the first one is an easy question. Is A or C 0? Basically, is there only one squared term in your equation? And if there's only one squared term, then it's a parabola. Plain and simple. If you got an x squared term or just a y squared term, and that's the only squared term, then you're looking at a parabola. If not, you got to think a little bit deeper. So the next thing to look for is when you have your equation like this, are the signs of A and C different? Is one of them positive and one of them negative? If that's the case, then you've got a hyperbola. And it's going to open up and down if it's got a positive y squared term, and left and right if it's got a positive x squared term. If that's not the case, so these are both positive, then you got to look a little further. If they're both positive and they're both equal, then you've got a circle. If not, well, the only thing left, you kind of eliminate everything else, then you've got an ellipse. So that's kind of a graphical approach to your thinking, or what I would consider a good way to think about these things. And let's see if we can't apply that to these shapes down here. What kind of a conic section am I looking at for A? Is it a parabola? Yeah, it's going to be a hyperbola, right? It's got two squared terms, so the answer to this first question is no. But the squared terms are opposite in sign, so this one's going to be a hyperbola. Hyperbola. Let's look at the next one. This one should be pretty easy. What kind of a conic section are we looking at here? Parabola. Good. Parabola. How about the one below that? Parabola. Now, technically, maybe you need to move everything to one side and write it as something like negative x, plus y squared minus 4y minus 5 equals 0. But you can see that there's only one squared term. So the bottom line in that one is that it's a parabola. Parabola. So, hey, cool.
That was easy.
This one we do need to play around with a little bit more. I would start by moving some of these terms, in fact, all these terms, to the other side. And the old saying that I use, when it changes sides, what else changes? Changes sides, changes signs. Well done. So it would be 25x squared minus 100x plus 25y squared plus 200y plus 275 equals 0. And at that point, I'm hoping this one's clear. Yeah. You've got two squared terms. Both of them are positive, and both of the coefficients of the squared terms are equal, so that one's a circle. Nice. Let's move down to the last part, E. So kind of like this previous one, I'm going to move things to the other side. 9 times x plus 3 squared plus 4 times y minus 2 squared equals 36. You don't necessarily have to square this out completely, and in order to figure out what the signs are going to be, etc. If I squared this out and distributed the 9, I'd have a 9x squared term, right? And over here I'd have a 4y squared term. So that should be enough for us to figure out what kind of a shape this is going to be. Ronnie, what do you think this one's going to be? All right, so we got two squared terms, so we're down here. Are the squared terms opposite in sign? No. So it branches us down to here. Are the squared terms equal? No. So that branches us over to an ellipse. All right. So thank you, sir. An ellipse. It's nice. It's nice to know what your graph's going to look like before you even get there. Now, a lot of times, if you're working with these equations, you can't easily put this stuff into your calculator. So it's especially nice to know that. Now, Desmos can work with these things. Desmos does a great job of that, but you're not always going to be able to use Desmos either. So let's do a few problems. We'll start with problem number 8. X squared plus y plus 2 squared over 4 equals 1. So there's a little bit of a difference here between this one and other ones that we've done before. But the big difference that I want to call your attention to is that the center is no longer 0, 0. We've shifted it. By the way, what should I write underneath the x squared term here? Yeah, I like 1 squared, even though 1 and 1 squared are the same thing. I like 1 squared a little bit better. But what's changed is that the center is no longer 0, 0. So what's the center going to be here for us then? Yeah, you want to look at the squared term and ask yourself, what makes that 0? 0. What makes this equal to 0? Negative 2. So there's your center, 0, negative 2. And let's graph that. On the back of your handout, the one we just had, you should see room for that. So let's plug our center in there at 0 and negative 2. Now keep in mind the scaling on this. So if this is 0, that's 2. That means this is 1. That's negative 1, negative 1, negative 2, negative 3, negative 4, etc. So there's our center. How far do I have to move to find the vertices in the x direction? 1. So 1 here and 1 here. How about in the y direction? How far do I have to move to find the vertices in the y direction? 2, right? So up 2 and down 2. So it's going to be here and here. Notice that these points are going to be exactly on the line, but you've got some other points that are really close to it. That's okay. We'll get to those in a minute. We'll play connect the dots. And Courtney, here's your wish. I'm going to do this live. All right. All right. And I'm probably going to flip it around here, so I'll make the viewing audience a little dizzy. So any graph that's not as nearly perfect as this one is going to lose points. All right, I'm kidding. All right, that one's not that great either, I don't think. But so far, so good, I hope. Nothing too much different than what we've done before, what we've done in Math 1150. There is one more thing that we need to account for, though, and that is the foci. So do you remember the formula for the foci? Yeah, it's one of these two. It's b squared minus a squared or a squared minus b squared, whichever one's going to give you a positive one. I always just write it this way and subtract them in the positive way, right? So 2 squared minus 1 squared means c equals plus or minus the square root of 3. Okay. So, nice. But where does that mean these points are then? What would the coordinates of those points be? 0, you got to be careful. That distance c is the distance that it's away from the center. So we got to start out at the center and move up root 3 and down by root 3. So our center we know had coordinates at 0, -2. Where are the foci going to lie? Well, good. That's a good start. 0. It has to be x equals 0 because we're on this line. So we're on the y-axis. And then you're going to have -2, -2 minus root 3, and -2 plus root 3. So you're going to have both of them. Now, on an exam, if I asked you for the coordinates of the foci, I would want this. But if you're graphing this, you probably take out your calculator and go, okay, so this is approximately -3.732 or something like that. And this would be like 0.0268 or something like that. -0.268-ish. Not that I'm going to ask you to graph it down to the nearest thousandth. I'm not sure why I put so much decimal digits there, but you could graph this yourself by coming up with some approximations. You could also let decimals graph it. Hey. Oh, cool. I gave you the decimals, gave you the approximations as well. How are we looking at problem number 8? Good there? Let's keep going. A couple more here. Let's try problem number 12 next. 9x squared minus 54x plus y squared plus 2y plus 46 equals 0. So, quick question for you. What kind of a conic section is this? You got to vote for an ellipse. Is she right? It's a circle? Well, let's take a look through things, right? Is there only one square term? No. There's more than one square term. Are the square terms opposite in sign? No. So you're down here. Do the square terms have the same coefficient? No. So if they had the same coefficient, then you'd be right. Then it'd be a circle. But this one is a special circle called an ellipse. Or actually, a circle is really a special ellipse, I should say that way. So let's shut this one off. And here's that equation. And wow, it certainly looks like an ellipse. So let's figure out what we can about this one in terms of the foci and stuff like that. So let's take a look here. In working with this one, I think the first thing I would do is send the 46 to the right-hand side and group these together. I'll factor out the 9 times x squared minus 6x. And even though there's nothing to factor out here, I am going to put them in parentheses like that. So that's our first step. The second step is a process that we've done before, and that is completing the square. I want to make the terms in each of these a perfect square trinomial. So, okay, how does that work? Well, let me remind you, you're going to take half of that middle coefficient. Half of that middle coefficient is 1, square it, and I get a 1 here. Now, if I put a 1 on the left-hand side, I should also put a 1 on the right-hand side. Okay, not so bad. Let's work with this one. 1/2 of what? -6. Half of -6 is -3. -3 squared is 9. But I'm not going to put a 9 on the right-hand side. Yeah, because by putting the 9 here, I've really added 9 times 9, or 81, to the left-hand side. I have to add 81 to the right-hand side to keep that in balance. So, looking good there. 9 times, well, this is something squared, and this is something squared. That adds up to, I think, 36. So, what do I square to get this? Good. X minus 3. This number here really helps you out down here. They're the same. And likewise with the 1 here. This is going to be y plus 1. So we're looking a lot better. A little bit more work to go here to kind of get this one into shape. And what I would do next is I would divide everything by 36. 9 cancels into 36 4 times, so this is x minus 3 squared over 4 plus y plus 1 squared over 36. And I'd probably tweak that one more time, right? X minus 3 squared over 2 squared plus y plus 1 squared over 6 squared equals 1. Yay. So what's the center on this one? Good. 3 and negative 1 is our center. Center is at 3 and negative 1. All right, so I think we're in good shape. Let's start graphing this. So got room for it here. So center is at 3 and negative 1. That would fit right there. How far do I have to move to find the vertices in the x direction? 2. Good. So it's going to be to the right 2 and to the left 2. How about in the y direction? How far do I have to move? 6. Did you get one? Okay. So up 6 would be here, and down 6 would be down here. Yep. So again, we get to play connect the dots. Courtney, I expect you to watch this in slow-mo. That was actually pretty good. Let's flip it around. Try the other way. Here's where I'll blow it. Actually, that's pretty good. Not bad. What's that? No. That's just this work. I'm not cheating. I'm not cheating. All right. So there's one last thing we got to figure out here, and that is the foci. So let's work on that. So the foci are going to be, c squared equals b squared minus a squared. So in this case, it's going to be 6 squared minus 2 squared, or 36 minus 4 is 32. So c is plus or minus a square root of 32. Really, it's only the positive root. C is not negative. You're just going to move positive and negative from the center. Now, the book would probably write that as 4 square roots of 2, having broken it up like this. That's fine. I'm not really that fussy about it. But what I would ask, though, is that you tell me the exact coordinates of the foci. So let's see here. Our center was at 3 and negative 1. The foci have to lie along this line, right? They have to lie along the major axis. So which coordinate am I going to change to get to the foci? Is she right? Yeah, you're going to change the y coordinate. So the foci are going to lie at 3 and negative 1 plus the square root or 4 square roots of 2, and 3 and negative 1 minus 4 square roots of 2. As far as graphing this is concerned, I don't want it terribly accurate. It doesn't have to be that great, but it should be at least be between the correct integers. This is about 4.7, and this is about negative 6.7. So that at least gives you a rough idea of where to draw these things, so that you're not drawing something down here when it really should be up here. It's going to be very close to your vertices. And that's going to happen when you have a very narrow ellipse or highly eccentric ellipse. So, looking good on problem 12. Thumbs up. Dwayne, yes. All right, good question. There's a couple of things you can do here. Really, if you want to be lazy, your calculator doesn't care if you rationalize this or if you do that. So you can do negative 1 plus the square root of 32 and get that. Or you can do negative 1 plus 4 square roots of 2, and you should get the same thing. So about 4.7. Now, if you've got one of these, then the cute trick is to get the other one, you hit the second key, then the enter key. Just go back and make that a minus. Now you got both.
Would you always get the same number if you don't square root? Like, let's say you have negative 1 plus square root of 30.
Oh, so if I go up here and do this one with a minus, yeah, it should get the same numbers. Yeah, so your calculator doesn't care if you've, made your mathematician teacher happy by tweaking the square root, getting the perfect squares out of the square root. George? No, I'm not really going to fuss with that. I mean, these problems are long enough that if your answer was 3 and negative 1 plus the square root of 32, I'm not going to care. All right, so good question. Anything else on problem number 12 here? Let's try problem number 16. Y squared equals 16x minus 8. Now, I kind of go back and forth a little bit on this one. The book does things maybe a little bit different than I do sometimes. Let's go back to our section on parabolas. One of the big things we're going to need to determine for a parabola is the focus and the directrix. And the focus and the directrix lie a distance of P away from the vertex. So how do you find P? Well, guess it depends on the way you write it. If you have the y squared term or the x squared term, if the squared term is by itself, then the coefficient of your other variable is 4 times P. And that's one way to do it. The other day we did things with a equals 1 over 4P, but this was the coefficient of your squared term. So basically you're just dividing this equation by 4P to get this one. In our case, we've got a y squared equals something, so we're going to work with that. So we're going to work with things this way. Since the y squared term is by itself, let me factor out the 16 here. And I know a lot of you gut instinct want to say, oh, that's x minus 2. It's not. It'd be x minus 8 over 16, or better yet, x minus 1/2. So it doesn't work out to a nice, perfect number here. That's okay. But here, we can kind of read off what to expect. That is, we can read off the vertex. Let's start out with the x-coordinate of the vertex. What would I put in here to make that 0? 1/2. And if I put in a 1/2, then all of a sudden I would have y squared equals 16 times 0, or basically y squared equals 0. So where does y equal 0? Or y squared equals 0? What do you square to get 0? 0. Yeah, so y would equal 0. So that's our vertex. All right, well, the other thing we have to figure out is what P is, so that we can figure out our our focus on our directrix. And the way we've written it here, 16 is equal to 4 times P. Well, that makes it pretty easy. What's P equal? P equals 4. Good. If P equals 4, we're in good shape. We can graph things and determine our focus and our directrix. Now, I don't think that we're going to have room on this graph for our directrix, at least not without sullying this really wonderful, perfect graph of my ellipse. So that's okay. The scale on this is 2, so that's 2. So 1/2 is going to be about here someplace. That's going to be my vertex. Which direction is this going to open? Left, right, or up, or down? I'm going to vote to the right. Could it open up or down? Why not? Yeah, we got a y term that's squared, not an x term that's squared. So this has to open either left or right. In this particular case, it opens to the right. In fact, if you wanted to figure out a little bit more about this graph and how it might open, let's just solve for x here. Let's graph a couple points. Now, your graphing calculator is not really going to be very good at graphing points for you here, because you have to solve for y in your graphing calculator. I mean, you could with the square root. Let's just do it this way. I'm going to move the 8 to the other side. You have y squared plus 8 equals 16x. And then divide everything through by 16, so it's going to be 1/16 y squared. 8 divided by 16 is 1/2 equals x. We've already graphed 0 for y, gave me 1/2 for x. But there's another easy point that I can plug in here. And that would be when y equals 4. Can you see why y equals 4 is going to be easy? 4 squared is 16. 1/16 of 16 is 1. 1 plus 1/2 would be 3/2. So if y is 4, x is 3/2. Would it matter if I put in a -4 here? -4 squared would still be 16 times 1/16. 1 plus 1/2. So I kind of get another one for free, right? Yeah, parabolas are going to have symmetric points. So let's see if we can't plot a couple of those. So 1.5 and 4, that's going to be about here and about here. So that's 4 and -4. So what you're seeing is you're going to have a very wide opening parabola. It's going to look something like this. And now inside our parabola someplace is going to be the focus. And that focus is going to be a distance of 4 away from the vertex. Let's think carefully about moving a distance of 4 away from the vertex. The vertex was at 1/2 and 0. Where's the focus going to be? which coordinate do I have to change in order to find the focus? Am I changing the x-coordinate or the y-coordinate? The x-coordinate, because you're moving horizontally. So we're going to change the x-coordinate. How far do I have to change it by? 4. So the focus is going to be 4 plus that. Focus is going to be 1/2 plus 4 and 0, or basically 4 and 1/2. So a little bit past here, out there on this scale. Now, I'm not going to have room to show it on my graph without really destroying this beautiful ellipse. But let's think about what the equation would be for the directrix. So I went 4 this direction to find the focus. I'm going to move 4 this direction to find the vertex. It's going to be a vertical line, but where's that vertical line going to be? So directrix is going to be 1/2 minus 4, or basically -3 and 1/2 for x. So that's going to be your vertex, or directrix. Please be careful. One of the things I'm going to want to see if I ask you for the directrix is x equal this. Y equals that would be a horizontal line. And if you just leave it off altogether, well, it doesn't tell me what it is. So make sure you give me x equals that for a vertical line. All right. I think we've nailed it for problem 16. Anything on 16 that you'd like me to recap? Go over a little bit more? Yes, sir. Oh, the 3/2 in both of these? So what I did was I took this equation up here and I solved for x. That way I could plug in values for y. And solving for x, I got this equation right here. So I wanted to choose some easy values to plug in for y. And I happen to notice that if I choose y equal 4, 4 squared is 16. 16 times 1/16 is 1. So that worked out pretty nice. So that's why I went with y equal 4. And if I have 1 plus 1/2, that's 1/2. Or another name for 1/2 is 3/2. So I got 4 for y, 3/2 for x. And since it doesn't matter if I square 4 or -4, I get kind of a point for free. Because if you put in -4 and square it, you get 16 times 1/16 is 1, plus 1/2 is 3/2 again. So that's where I got those 2 points. Now, as part of your test, your exam, I'm not going to be asking you to necessarily do something like that. I'd probably just be content having you find the equation of the directrix or find the coordinates of the vertex and focus, that kind of thing. This one, I'm not sure. I'd be asking you to graph this one. All right. Thanks for the question. Anything else on problem 16? Let's see. Let's try another follow-up problem to keep working with parabolas for one more iteration. I think problem number 46. So 46. So what's the equation of that parabola? All right, well, I guess that's what we've got to figure out. First things first, though. Is this going to be a parabola in x squared or in y squared? All right, so it's going to be a parabola in x squared because it opens down, right? In fact, it has to be a negative x squared term somehow because it opens down. So let's write something like this. The general form of equation of a parabola would be, let's see, y equals a times x minus h squared plus k. H and k are your vertex here. Well, we know h and k, right? There's h, there's k. So we're in good shape. let's see here. That's going to be y equals a times x minus 4 squared plus negative 1. What's a better way to write that instead of plus negative 1? Just minus 1. Thank you. All right. Well, I still need to figure out what a is. I'm open to ideas. Let me point out, though, that this parabola passes through this point. What are the coordinates of this point? 6, negative 2. So to find the value of a, what could we do? Yeah, plug them in for x and y. So this is x and this is y. So that means negative 2 equals a times 6 minus 4 squared minus 1. We'll add 1 to both sides and get negative 1 equals a times 2 squared is 4. So, wow, there you go. A is negative 1/4. Overall, my equation looks like this. Y equals negative 1/4 times x minus 4 squared No. You couldn't subtract those. What I did is I added 1 to both sides first. 1 here and 1 here, so that negative 2 plus 1 gave me negative 1. Squaring that is 4. You can't combine those two because you would have an a squared, like a 4a squared minus 1. They're not like terms, so you can't get like a 3a squared. So it's all right. I appreciate you checking me on that, though. So there's our equation. But let's practice with this a little bit more. Before I go on and do a little bit more with that, are we okay with where we're at? Where we got our equation from? All right. So this is cool. I can kind of look over in this general direction and say, Farrah, do you understand? I should get an answer from somebody. All right. Let's keep going. Now, there's an equation that we can use to help us find P, and that is P equals 1 over 4a. So I'm trying to think where I want to write that. P equals 1 over 4 times a. So 1 over 4 times what? Negative 1/4. So what does P equal? Yeah, P equals 1 or negative 1. I don't really worry about the sign so much. I just understand the orientation. So what it's saying is that to find the focus, I need to move a distance of 1 inside here. So what would be the coordinates of my new point here? If I move a distance of 1 from this point. By the way, do we have to move up, down, left, or right 1 to find the focus? We're going to move down, right? So, so this is going to be 4, negative 2. How about the directrix? Where's the directrix? So the directrix is going to have to pass through this point. Thank you, Sam. Passes through this point. In fact, it's going to be a line. It's going to be this horizontal line right here. What's the equation of that line, Ann? Thank you. Y equals 0. So there's your directrix, there's your focus, and there's your vertex. So kind of a nice problem to bring all 4 of those things together. Anything else on problem 46? Kind of by way of a wrap-up on that? Dwayne? So, in general, the way that a parabola is defined is that it's a set of points that at the same time are the same distance away from the focus and the directrix. So this distance there and this distance here should be the same no matter what point on the parabola that you choose. You don't have to remember the definition so much, as what you do have to remember is that the parabola is going to open around your focus and away from this line called the directrix. Those are the big points that you need to keep in mind when you're graphing the parabola. It opens around the focus and away from the directrix. To find the directrix or the focus, you need to find this distance P. And P is going to be determined from this equation. A equals 1 over 4P, or P equals 1 over 4A. Either way. So, now the way the book wrote it here, this number is 4 times P. I like to think of A as being the coefficient of your squared term, so we're a little bit different in terms of our preference, but either way works. And what do? Well, in our problem, we had the coefficient of your squared term. That's your A. And so we plugged it into this formula to find P. And P, we can ignore the sign. P is a distance of 1. Oh, thank you. I'm sorry. Yeah, sometimes I tilt this, and so when it's underneath here, it's not pointing at the right thing. Thank you. So we figured out that A was 1/4. We put it in here to find P. P turned out to be -1. You can just keep in mind that P is 1. So a distance of 1 from the vertex means you're going to go down so that your parabola envelops, or the focus is inside the parabola. Down 1 from that gives you coordinates at 4 and -2. Up 1 from that puts you on this line, and that line is at y equals 0. So Dwayne, okay, thank you. Anything else on 46? Let's try problem 24. Y minus 1 squared over 25 minus x plus 3 squared equals 1. What kind of a graph is this going to be? Yeah, it's going to be a hyperbola. Now, I should probably rewrite this, Janae. How would you suggest I rewrite this?
With 5 squared and 1 squared underneath the x plus 3.
Perfect. A 5 squared and a 1 squared. Now, kind of a trick question here. Not intentionally, but just by the nature of this. What's the center of this? Yeah, it's really tempting to just read it left to right, x and y. 1, -3, but that's flipped, right? It's -3 for x, -3 for x, and 1 for y. So you got to be a little bit careful there. With the terms that have the y in front, yeah, it's comfortable to say, oh, x and y, but it's backwards from there. So let's see about graphing this. All right, so the center is at -3 and 1. So let's see here. On this scale, so this would be -4 here, so this would be -3 and 1. Be right there. So there's our center at -3 and 1. I need to draw the box or the rectangle so that I can draw the vertices and the asymptotes. So how far do I have to move in the y direction to find the vertices? Up by 5. So 1, 2, 3, 4, 5. So right up here on the line for y equals 6. And then 1, 2, 3, 4, 5. Down here on the line for y equals -4. Those are 2 of my vertices. 2 of the spots I'm going to use to draw that box. I need 2 more. How else am I going to find those? What else do I got to do? Yeah, they are a unit of 2. So 1, 2, 3, 4, 5. Right? Or 2, 4, and then a half or 1 more there. So yeah, those are right. All right, 2, 4, and 6. -2, -4. But we started at 1, right? It's okay. How about the other sides of my box? How far do I got to move? Just 1, right? So it's going to be a really narrow box. It's okay. Let's just draw it and go with it. So here and there. 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 Not only is it going to be a narrow rectangle here, but it's also going to be a very narrow hyperbola. So let's keep going. Just by the way, if when you're drawing this, if the diagonals don't cross right at the center, or at least reasonably close, then you might have made a mistake. You probably did make a mistake. These 2 lines, these asymptotes, should pass directly through the center of your hyperbola. If they don't, look back. Chances are you may be miscounted in drawing something one way or another. So there's my 2 asymptotes. Then there, there, there. Now I understand that you might not be perfect in drawing these things. The only thing I don't want is you to egregiously cross this line. I mean, to go out here, or to bounce off of it as if it's like the edges of a pool table and come back in. Other than that, you should be fine. Just draw something nice and smooth there for me. There's one last thing that we need to calculate there. What is it, Fadi? Yeah, the foci. So the foci have a slightly different formula than they do with the ellipse. C squared equals what? If you accidentally used a squared minus b squared, you'd get 5 squared minus this would be the square root of 24. And the square root of 24 would be putting you right here and here. And instead, you know your foci have to lie inside each branch of the hyperbola. So hopefully if you use the wrong formula and you see, oh, wait a minute, these aren't in the right spot, that it would fix itself. You'd say, oh, I got to use the wrong or the other formula. So 5 squared plus 1 squared gives me c squared equals 26, or c equals the square root of 26. Okay, that's great. But let's find the actual coordinates then. So I know that I have to move a distance of the square root of 26 from here, which is going to put me barely inside here and barely inside here. But see if you can't write down the exact coordinates. Write them down before I do without looking up here. No, I want exact values, not decimals. But you're right, it's about, the square root of 26 is about 5.1. So since we're changing things up and down, we're going to have to change the y coordinate. So it's going to be 1 plus the square root of 26 and 1 minus the square root of 26. Yeah, this is the ones that I want. Oh, you want to go from like 0, 0 or from the center or something? Okay. Yeah. And then you can use your calculator to get approximate decimal values from here if you want or need. Cool. I think we got everything there for problem number 24. Looking good there? It is. It is, but there's a good way to get proficient at this. You know what it is? Practice. Yeah, all right. Yeah, sorry. Boo-hoo. Yeah, it's not what you wanted to hear. Yeah. Calculator tricks are in a different video. Sorry. Anything else on 24 here? Yes. As far as the foci are concerned, I mean, you probably get one problem where I ask you to graph them, and your graph should look reasonable, meaning I expect the foci to be somewhere close to the vertex. If you're drawing the foci up here, well, then you're pretty far off. Right. So it's just to give you an approximate of where to put it. Yeah. Yeah. If all I asked you for was where are the foci, this is all you need to write. So yeah, the approximation is just for our own benefit. Okay. Last one here, problem number 36. They give us some vertices, so I'll call it V1 and V2, -1, -4, and -1, 6. Vertices of an ellipse, and the foci of an ellipse, -1, -3, and second foci would be -1 and 5. So, okay. Let's graph that. See if we can't determine the equation of this ellipse. So, let's see. No, it doesn't, which is frightfully annoying to me. The graph on the sheet doesn't exactly match up. So we're going to have to do this one freestyle, which is why I drew my own graph. Yeah, how about that? Let's see. So let's label a few points. We've got vertices and foci. So I guess I got to take a step to the left. So I'll just put a point over here. So I've got a vertex at -1 and 6, which is all the way up here, and at -1 and -4, which is down here. So there's my vertex. So V2 and V1. And then also along this line, I have some foci. So I got foci at -1 and 5. So that's F2, and then -1 and -3, F1. I want to come up with the equation of an ellipse. And in general, it has to look like this. So, okay. Well, I guess a good place to start would be, well, what's the center of this? Right? What's H and K? Oh, well done. One of those coordinates should be pretty easy, right? the center has to lie on this line. So the x-coordinate of the center has to be -1. As far as the y-coordinate, who's able to get that one? Sam? All right. How'd you find the y-coordinate of the center? Perfect. So what you can do is you can average these things. So in the middle of these 2 points is going to be your center. So if you average those 2 points, -3 plus 5 divided by 2 gives you 2 over 2 or 1. So well done, Sam. Thank you. -1 and 1. You could also use the average of -4 and 6 to get that as well. But here we go. There's your center. And knowing the center tells us something else about our problem, right? There's 4 things we need to know. We now know h and k. We can also look at this and figure out one of these other values. Not a. Michael? Do you see what other value we can determine here? Tell you what, let me help out a little bit. That distance there is b, right? It's the distance from the center to your vertex in the y direction. So what's b equal? Well, 6 minus 1 would be 5. So far we've got h, k, and b. So our ellipse looks like, well, we can plug in those. It's going to be x plus 1 squared over a squared plus y minus 1 squared over 5 squared equals 1. One last thing I need to determine, and that's a. Wow, almost done. What can I do to determine a? That would be if you're working with a parabola. C squared equals 5 squared minus a squared. Well, what's c squared? What's c? Not quite. C is going to be this distance. C is the distance between your center and one of the foci. So what's that distance? 4. So putting that all together, I get 4 squared equals 5 squared minus a squared, or a squared equals 5 squared minus 4 squared, which is 25 minus 16. What does a equal? 3. Let's put that in for our final equation. X plus 1 squared over 3 squared plus y minus 1 squared over 5 squared equals 1. Whew! Yay! Wow. For homework, try 5 through 59. You can skip problem number 45.